Welcome back to our video number 6. And I have a question. How's your summer going? Okay. Well, anyway, by the time we get around to firecracker time, you will have this course completed. And I must say at this time that you folks are doing a job. I'm proud of you, so I hope you keep up the good work. Today, what we're going to be doing is we're going to take raw data and we're going to start cooking the data. Now, this will continue on through Z and T and probability and so forth. And I still want to emphasize that I believe it's very important to write this material down. You can work it in your calculator. On Google, they have all types of calculators for any operation I believe that you want to perform, and they are fast. But today, we're going to be starting on the sum of squares, variance, and standard deviation. Now, your text on pages 77 to 80 covers this material also. And your text takes a little bit different approach. It explains it in a verbal sense that I kind of enjoy reading through there, particularly if you go back and forth and between the text and video. But what we have today is the sum of the squares, which is designated SS, variance, sigma. This here is sigma squared down to standard deviation. And this is a sign that looks like a zero with a little tail on it. I haven't really developed a good method yet with my scientific notation. I see that some of you folks have, and that's great. I really appreciate it. Well, this is on the text, page 77 to 80, and we're going to be going from raw data, like I said, raw data to cooked data. First of all, we're going to take the sum of the squares. Now, we have our data here on this side, and this is one thing that I want to emphasize is because you will be working with data. And it is not necessary to put in a large amount of numbers. I mean, just numbers, numbers, numbers. We are focusing in more on the process than we are in just stretching this out. So there will not be a lot of numbers used in this course for the most part. But here we have X. This is our data. Data X. We have you can take whatever you want to. You can take what individuals got on a test. And we have the data here, 1, 0, 6, 1. Well, the sum of X added up is 8. So if we add this up, 1 and 0 and 6 is 7 and one more is 8. And we have that here. We have the sum of that elusive little sum of sign, the funny looking E. If you don't remember anything about stats, remember that it's the course with the funny looking E. Now, if we take an average of this, and this is basically what we are doing, is taking an average. The only thing is we are doing this statistically. And so we would take the 8, and we would divide it by 4, because that's how much data we have. We have 4n here. And so we have mu, which is the statistical way of saying the average. And we have mu, and mu equals 2. Now, over here on this side, we have the data minus the mean, or mu, and we have a -1 and a -2 positive 4, and a negative 1. So now we're looking at the sum of the squares. And we have those added up, and then we take those and we square them. Now, one of the reasons that we do this is because the statisticians were working along in their stats. They said, wait a minute, something wrong here. We have some negative numbers. What are we going to do with those negative numbers? We have to get rid of them. You know, these statisticians are sharp. And so they said, I know how we can do that. We'll just square them. And that's what they did. And so then we squared them. So we wind up with the sum of the squares. And that's what we have right here. We have the sum of the squares. We have 1 squared. Negative 2 squared is positive 4. And then we have 4 squared, and that is 16. And then we have a negative 1 squared, and that is 1. So if we add those up, we have 22. Now we're looking at the variance. The variance is the sum of the squares, and I will stop right now and mention this. Some of you probably have your calculator, and you can go through and you can do these operations. And again, I've said this before, but again, in Google, you can Google calculators, you can put your information into the calculator, and you can go ahead and come up with the proper response. So if you want to go that way, that's fine, even though it is good to, I think, know the operation as we are going through it so we know what material is being presented. And in this here, we have the variance, which is the sum of the squares, which is 22 divided by our n. You see this n here? This is for a population. All the sigma and the mu and the n here is all for a population. We will be talking about a sample a little bit later on, and that changes how we use the n and the mu, or the mean, and the standard deviation. But we have the sum of the squares divided by 22, and we have 22 divided by 4, excuse me, and that is 5.5. So our variance then is 5.5. Okay, so we've gone through the sum of the squares, and basically what this is for is when someone says to you about sum of the squares, or you hear the term sum of the squares, you'll know what it means, and also with the variance, you will know what it means. So we have variance here, sigma squared, variance, and then we have our standard deviation. Now, here's a computational formula for variance. We have SS over n, 22 divided by 4, and then we have come up with 5.5. Now, for the standard deviation, it is basically the same thing, only we find the square root of the 22 and the n, which is 4, and that gives us our standard deviation, which is 2.34. Now, remember that the mean for this is 2, and our standard deviation is 2.34. So that is how we find the standard deviation, and this is the value that's given to each standard deviation. You will have some more videos that explain this, and hopefully you will be able to see a little bit better how it works. Remember, in our standard deviation on our mesocurtic curve. The standard deviation, we have 34% below the mean, 34% above the mean. And then the next standard deviation is 13 and 13, and then a little over 2. Now, I'm not really particular about the percentages, but we should be getting very close because each of the standard deviations does have a percentage, and so we should be getting real close with the material. Now, if you have any questions, or possibly at times I may have erred in my calculations, I will say that. If I have erred in my calculations, you can draw my attention to it. It doesn't bother me, it doesn't offend me, because I've watched some videos, I've read some books on stats and some of the texts, and I remember that on occasion we would find some errors. So if you do find an error, notify me of it. I have no problem with that. We are going to be moving on to Z as in zebra, and T as in the tea that you drink, scores, and hopefully you will have these scores processed in your mind. I think it's important to process these scores as we go because it really helps with the future. So until we see you next time and visit a little bit more, we'll see you and have a good day.